Hey everyone, ready for another deep dive into the world of AI? This time we're going to be talking about something that's really pushing the boundaries. How to make those amazing large language models, the LLMs we hear so much about, even better at multi-step reasoning.
Ooh, that's a good one. Multi-step reasoning. It's kind of like when you solve a math problem, right? Each step builds on the last one.
Yeah, exactly. Or when you're planning a trip and you got to figure out the best route with all the stops and everything. It's something we humans do all the time, but it's a real challenge for AI.
Absolutely. And that's where this paper we're looking at today comes in. It's called, get this, Offline Reinforcement Learning for LLM Multi-Step Reasoning.
Okay, that's a mouthful, but don't worry, we're here to break it down and make it digestible. So what's the big deal with this paper? Why is it so groundbreaking?
Well, it introduces this really cool new approach called Oreo.
Oreo, like the cookie. Now you've got my attention.
Yep, just like the cookie. It stands for Offline Reasoning Optimization. Catchy, right?
I like it. So tell me more. What makes Oreo so special? Why all the hype?
Okay, so think about how we usually train LLMs to reason. It often involves tons of data or letting them interact with the environment, like trial and error. It can be super time consuming and resource heavy.
Yeah, I can imagine. Like a robot trying to make a sandwich a million different ways before figuring out the right one.
Exactly. But what if we could teach the LLM to reason without all that trial and error? That's where Oreo comes in. It works offline, meaning it learns from existing data.
So no more wasted sandwiches. I like the sound of that. But how does Oreo actually do that? What's the magic behind it?
Well, it uses this clever combo of a policy model and a value function. The policy model is kind of like a guide, telling the LLM what actions to take, and the value function is like a critic, predicting how good those actions will be.
Okay, so they're like a dynamic duo working together to make sure the LLM's on the right track.
Precisely. And get this, they learn together by trying to satisfy this special equation called the Soft-Bellman equation. Don't worry, we won't get too deep into the math, but the key takeaway is that this equation helps the model learn from both its successes and its failures.
So it's not just about being told what to do, but also understanding why certain actions are better, even if they don't immediately lead to the desired outcome, like learning from your mistakes.
Yes, exactly. And that's one of the big advantages Oreo has over another method called direct preference optimization, or DPO.
DPO. How is Oreo different from DPO?
So DPO needs a lot of hand-holding. It requires data where someone has actually compared two solutions and said which one is better, but Oreo doesn't need that. It's more independent.
Oh, interesting. So less hand-holding, more self-discovery. But does this actually translate to better performance? Does Oreo really deliver the goods?
Welcome back. Now let's dive into some actual results. Remember those math reasoning benchmarks we talked about? GSM 8K and math, those are
Right.
pretty tough tests for LLMs.
Yeah, like the AI equivalent of the SATs. So how did Oreo do?
It aced them. On GSM 8K, Oreo achieved a 77.3% accuracy. That's a 5.2% improvement over the baseline. And remember, we're talking about a model with 1.5 billion parameters.
Wow, that's a lot of brain power. So it's not just getting the right answer, but doing it with a high level of accuracy.
Exactly. And on the math data set, which is even tougher, Oreo got 52.5% accuracy with the same model size. That's a 10.5% improvement.
That's incredible. Imagine what that kind of problem-solving ability could do in fields like finance or engineering.
Absolutely. And the best part is it's all done offline, using existing data. No need for expensive simulations or anything like that.
That's a game changer for efficiency.
Huh.
You also mentioned Oreo being tested on a simulated robot in a house-like environment. What happened there?
Right. They use this platform called ALF World. It's like a simulated house where the robot has to complete different tasks, things like navigating to a room or finding a hidden object, stuff that requires reasoning and planning.
Sounds like a challenge. How did Oreo handle it?
It did amazingly well. It achieved a 79.1% success rate in unseen environments.
Unseen environments. You mean the robot had no prior knowledge of the layout?
Yeah, no map, no cheat sheet, nothing. It shows that Oreo can actually generalize its knowledge and apply it to new situations.
Okay, I'm really starting to see why everyone's so excited about Oreo. It's efficient, effective, and adaptable. But didn't you say it was also iterative? What does that even mean?
Ah, yes. This is where it gets even cooler. Think of it like practicing a skill. The more you do it, the better you get. Oreo works the same way. It keeps learning and improving over time.
So it's not just a one-time learning process, it's constantly building on its knowledge.
Exactly. The researchers actually ran Oreo through multiple iterations and saw significant improvement with each one. It's a system that's designed to grow and evolve.
That's mind-blowing. This is giving me a lot of hope for the future of AI.
Yeah.
But let's get back to the research for a second. You mentioned some potential limitations. What are some of the challenges that still need to be addressed?
Well, one thing to remember is that Oreo is only as good as the data it learns from. If the data is biased or inaccurate, it could affect the model's performance.
That makes sense. So it's important to have diverse and representative data sets for training these models.
Absolutely. And another challenge is scalability. The researchers tested Oreo on models with up to 7 billion parameters, but there are even bigger models out there.
7 billion parameters. That's already massive.
I know, right? But some models have hundreds of billions. Figuring out how to scale Oreo to work with those is a big challenge.
So it's all about making Oreo even more powerful and efficient so it can handle those increasingly complex LLMs.
Exactly. It's an exciting area of research, and I'm sure we'll see some major breakthroughs in the next few years.
This feels like just the beginning of the Oreo revolution. But before we wrap up this part, I got to ask, we've been talking a lot about Oreo the method, but what about Oreo the cookie? Any connection there?
Hmm.